Welcome to a quick lesson on exterior angles. So in our last lesson we learned about interior angles, and you can look at our right hand side. There's a diagram there that shows you the difference between interior and exterior angles. So an interior angle was on the inside of our polygon, and the exterior angles on the outside of the polygon connected with a side and an added extension of an adjacent side. So our definition then for an exterior angle, it's an angle outside the polygon formed by one of its sides and an extension of an adjacent side. So as a note, when you add up the interior angle and the exterior angle, you're going to get a straight line that adds up to 180. So we take again at the diagram, if you add the 150 exterior angle with the 30-degree interior angle, that gives us a full 180 degrees. Here's another note. Exterior angles of any polygon always add up to 360. So if you add up all the exterior angles together, it would be 360 degrees. Here's some formulas that we're going to use. An exterior angle, we can find that by taking 180, subtract the interior angle. Another thing you could do is find the interior angle, which is 180, subtract the exterior angle. So again, you can also find the interior by taking 180, subtract the exterior angle. The number of sides of a polygon can be found as 360 degrees divided by the exterior angle. That is another formula that we can use. So we can find the number of sides of the polygon if we take 360 divided by the exterior angles. And again, you need to have a regular polygon for this to work. So only use this formula if you have a regular polygon. Before we begin and do some examples, I'm going to draw one more diagram so you have an example of what an exterior angle could look like. So I'm going to start off by drawing a parallelogram. It has two parallel sides here and then another. So that's what a parallelogram looks like. And if I want to draw an exterior angle, according to our definition, we're going to extend one of its adjacent sides, so this one. And then this angle is on the outside of our polygon. This is your exterior angle. That's just another diagram if you want another example of what an exterior angle could look like. So let's go ahead and do some calculations then. We have a regular polygon, okay, has an equal exterior angle of 72 degrees. We'll want to find the size of each interior angle in the regular polygon. Since we're looking for the interior angle, I am then going to use this one here, because that's what we're looking for, and we're given the exterior angle. So, your interior angle is equal to 180 minus the exterior angle, which is 72 degrees. In total, this is 108 degrees. Next question, find the number of sides in that regular polygon. So that would be this one here that we're going to use. The number of sides of a polygon is 360 divided by the exterior angle. So the number of sides of a polygon is equal to 360 divided by exterior angle, which is 72 degrees. That number is 5. 360 divided by 72 is 5. So we have a 5-sided polygon, which means that we have a pentagon here. Determine the sum of the exterior angles of an octagon. If you look at our highlighted note, it says exterior angles of any polygon always add up to 360. So the sum which means we're adding of the exterior angles of an octagon is going to be 360. Our last example, determine the size of one exterior angle of a regular decagon. A decagon has 10 sides. So we know the number of sides of the polygon. We're looking for the exterior angle. I'm going to use this formula where the number of sides of our polygon is 360 divided by the exterior angle. So the number of sides we know, I'm going to replace that with the number 10, is equal to 360 over the exterior angle. I'm going to call that EA. Now to find this, I'm going to multiply both sides by that EA and divide both sides by 10. Or in other words, I am going to switch the position between these two, which is 360 divided by 10. That's 36 degrees. So our exterior angle inside, or our exterior angle for a decagon is 36 degrees.